Alright, problem number 17, you're supposed to find the absolute value of 2 minus 5i. Okay? If you recall, we talked about graphing absolute value and absolute values, complex numbers. And to do that, we had a real axis and an imaginary axis. Okay? So when we graph 2 minus 5i, 2 is the real part, so we mark off 2 in the real. Negative 5 is on the imaginary, so we go down 5 on the imaginary axis. And so that point is somewhere down there. Now, that's not exactly where it's at, but that's a pretty good approximation. Now, when we say what's the absolute value for this number, we're asking how far this number is away from the origin. So we're looking for this distance right there, that purple line. How long is that? If we had a ruler, we would measure that thing, assuming our scale was all set up, but we don't. So what we do is we just realize that that purple line is part of a triangle. Okay, and that's the hypotenuse of it. And the legs of the triangle are 5 and 2. And that's where we use the Pythagorean theorem to figure out how long the purple line is, because that is the hypotenuse of that triangle. So we use a squared plus b squared equals c squared. A and b are the legs. Doesn't matter whether you put 2 for a or 2b, 2 is b and 5 is a. C squared up there. And so we just do the math. 4 plus 25 equals c squared. And so c is we have to square root both sides, and that's a 29. 4 plus 25. So this side right here, that hypotenuse, is root 29 long. That's about, I don't know, 5 point something. Let's see. 63, that's about 5.5 approximately. And your calculator, if you just type this in, absolute value of 2 minus 5i, it will give you the decimal value. But the question asked for the exact value, and so we want to just leave our answer like that. Okay, that should help you also with number 18, because 18, we're just graphing 3 minus 2i. And so if I use the same axis that I have drawn for number 17, number 18, 3 in the real would put you out here, one more than the 2 was, and minus 2 would put you right about there, right on top of where that 5 is, because that's about 2 down in the imaginary. So you don't have to draw any lines to indicate where that red dot is, other than to say, hey, I'm, 3 over and I'm 2 down. That was 3 minus 2i. 2 down, so we just need to put our tick marks, but we don't connect it to the origin or anything. That was just to find the absolute value. Number 19, we're just multiplying two complex numbers. You could actually throw this one into your calculator as long as you are in complex mode, but we should know how to do it without our calculator. And to do it, we just distribute the negative 5. So negative 5 times 7, negative 35. And negative 5 times negative 4i is positive 20i. Then we distribute 2i to both of those terms. 2i times 7 is 14i. And then the tricky one is 2i times negative 4i is negative. The 2 times 4 gives us 8, but the I times I gives us I squared. Now we have to know that I squared equals negative 1, and therefore that is negative 8 times negative 1, which is positive 8. So we've got negative 35. These are like terms. And we add those. That's 34i. The negative 8i squared became positive 8. These are like terms, that's negative 27 plus 34i. It's an ugly 34i. And so there it is. We've multiplied those two complex numbers, and we got another complex answer. Finally, number 20. We're just cleaning this up. Now notice this isn't a distributing property. This is just subtract one complex number from another one. And so this is 9 plus 10i. We distribute this negative 1 because we want the opposite of all that, and that becomes a plus 7 and a minus 4i. And now we add the real parts, and we combine the imaginary parts, and we are done. We can't combine those two. You can't combine a real and imaginary. So hopefully you get this tonight and it works. Good luck at the orthodontist, and I will see you 4th hour for the test. If you have more questions, I'll be up for a little while. So email and I'll try to answer.